the IoT gateway is our most important and most critical part of the Internet of Things ecosystem, the IoT ecosystem. The IoT gateway, as we said, that it resides between the cloud and the sensors or devices. CLOUD. These are our sensors or devices. This is data communication going on between the sensor devices and the gateway. So the term gateway, why we use the term gateway? I mean, the term gateway is actually very familiar for us from the history. We have been using gateway term for example, any kind of devices that were doing protocol translation. Protocol translation means like these converting one networking protocol to another protocol, or switching between the devices or the connected, computers or anything, and for the system management. So an example of a gateway, a traditional old gateway, is for example our router that we use for the LAN and Wi-Fi connections. We have with this router, for example, we have an antenna, and then some computers are connected to it, or our mm, Wi-Fi devices like mobile phones that are connected to it, and this is assigning. This has an external IP address. This IP address it obtains from the global internet, from the ISP provider. Sorry, from the ISP provider, and then this converts this IP address to its local IP address, and then all of these nodes have an IP address, and it can kind of communicate the data between the ISP and these nodes. So this is our traditional old gateway, uh, and that was it's kind of an example of one of our old traditional gateways. So it was quite simple, but now the modern IoT gateway is quite intelligent. It has, for example, a storage on it. Also, we should write that it has an OS, not OS, an operating system on it. For example, Linux, Windows, and now recently we also have Android OS also on certain gateways. Um, and the next feature is it filters the data and processes the data. It filters the data that is coming from these nodes and processes it, stores it, analyzes it, or whatever you can say. It's kind of, this it also has a source code inside it, this gateway, and using this source code, it does the intelligent processing of the data and then sends the processed information to the gateway. Because if it sends all the information as it is, that it is getting from the nodes to the cloud, then it's not a very efficient system. Actually, there's a lot of overhead, a lot of tasks for this cloud, or our presentation or service layer. This has a lot of tasks to do. So most of the things we are doing at the in terms of the data processing are doing at the gateway levels, and it then does also the traditional network protocol translation and integration and connectivity to thousands of devices. For example, on a normal gateway, we can have for example, Wi-Fi. We can have Bluetooth. We can have GSM. UMTS. We can have radio transmission on a normal gateway. It can support, for example, the new IoT protocols like LoRa, 6LoWPAN, 6LoWPAN, CoAP, MQTT, etc. So as said, the gateway becomes very critical part of the IoT ecosystem because these nodes consider, for example, they are measuring, there are some temperature sensors or noise sensors or humidity sensors or positioning sensors or flow sensors or any kind of sensors, or maybe some kind of control appliances for lights, devices for controlling, for example, lights, fans, ACs, or anything, or any sensors or devices on your cars. Uh, they can be thousands of these devices, and all these devices may have thousands of different networking protocols. They might have, for example, a lot of data to send. They need, for example, a lot of battery life. And it might be low power devices. Because we cannot afford to charge to recharge so many hundreds and thousands of devices. Every other day. They need to send so much to this gateway. So this gateway has become very important because the conversion of all these protocols to the one that are going to send data in this direction, uh, is or and also from also be able to, for example, collect data from these devices using different protocols like as I said, LoRaWAN, 6LoWPAN, or MQTT, or CoAP, or Zigbee, whatever. This can be only managed by a device called gateway, which is given all these features, or which has all these implemented features to manage all these protocols, for example. So the gateway is, that's why has become a very critical part of the IoT ecosystem. So this gateway has in its storage space a software, an embedded software, embedded software that makes it possible, for example, to collect data from all these sensors that are sending data maybe from several different networking, using several different networking protocols, and then it processes this data, analyzes this data, and sends it using some other networking protocol to the cloud, or any one of these protocols that it has taken the data as input from. So this is kind of a, you can say, an implementation, or of a gateway, that it will have the ability to translate the protocols, to kind of integrate these networking protocols in it, and then have an embedded software installed in it, and the sensors are all lying outside. But there can be situations, for example, where we might, I think I should use a blue pen now, where we might have, for example, a few sensors also on our gateway. And such kind of sensors, for example, the GPS sensor, this positioning sensor, GPS sensor, for example, we can have on the gateway. We can also have, for example, a temperature sensor on the gateway, and humidity or flow sensor, some liquid or water flow sensor. You can have any of these sensors here, and the data let's say the data from this sensor is D1, D2 from here, D3 and D4. So this all data will be processed with the help of this software, analyzed, collected, and when, for example, it is ready to send, it will be and also our cloud, for example, is ready to accept the data. This collected, this will be the data, you can say, wait a second. uh, yeah, so can be our this is our processed data, that is the output. Processed data, process and collected data that is going to our cloud. So we have talked about two kinds of gateways. Number one, uh, without sensors, without sensors on board. On board means, there were these sensors. Without these sensors, this is one, and then two is with these sensors on board. With sensors on board, all other things are the same. Now we can analyze maybe now that what kind of what are all the, we can try to design a gateway by ourselves. That what kind of we can try to select, for example, our communication hardware, our embedded hardware, our storage, and you know all those things we can, and our sensors maybe if we need on the gateway. So we can try to find a way how we would like to, how we would make a gateway in the next. So in order to design a gateway, we should uh, keep the following things in mind. What our gate should have. Number one, our gateway should have interface for example, Wi-Fi or WLAN, or for example, Bluetooth. Bluetooth, not WLAN, because Wi-Fi is the same as WLAN. LAN, I mean. So, with LAN and Wi-Fi options in it, it should be able to easily connect to the local area network. This should be the minimum at least required, that it should be able to connect to the local area network. With Bluetooth, for example, we have the advantage of offline connection. For example, it can connect to our mobile device or any Bluetooth device, the gateway, and then send the data to and fro to this device. This should be at least a minimum requirement. And then we can also have, for example, a GSM module on it, which will support GSM and UMTS. And what next? Number two, our gateway should have should have interfaces to support the IoT protocols, the latest IoT protocols. For example, CoAP, uh, MQTT, and mm, LoRa, 6LoWPAN. Zigbee, remember, we don't need to have all these. For example, we can choose only the GSM module and use, for example, GSM or UMTS, and from these interfaces, for example, to communicate with our low power devices, we can use, for example, QoAP or MQTT, or just one of them, or with a combination of 6LoWPAN, uh, anyway, to implement QoAP or MQTT or 6LoWPAN or LoRa, we need the RF interface as well. For example, LoRa we can implement using a LoRa chip that we can buy from the market. And number 3, we need a device with storage, for example, plus an operating system, plus storage, plus OS, in order to store our software in it, for example, that is going to kind of collect the data and kind of process it and analyze it and send it to the other direction, and in actually bidirectional. So what can we choose for this? What can be this device? This could be a small on-chip computer like we have in the market. These Arduino microcontrollers, or Arduino chips, whatever you call them, controllers. And then you can have, for example, a Raspberry Pi board, you can use this as well for this purpose. Number 4, very important factor, is encryption, data encryption and security. For example, the data that we send from the gateway to the devices, or from the gateway to the cloud, should be encrypted, because we don't want that somebody is sniffing the data in this wireless communication procedure. And then if there is no security, many of our customers will not like to buy our system or gateway. Plus this is this data encryption. This is also security. What is this security? Security of devices, you can say. For example, there should be a way that our gateway is able to kind of connect only to the devices which are authenticated by us or by our company. It's kind of identifying the devices in a particular ecosystem. For example, you can maybe have some pre-shared keys in your IoT devices, so that your gateway knows that these IoT devices belong to our particular application, and it can trust the data coming from these applications, or it has to process the data coming from these devices.